Why, hello again. This is my attempt to explain stoichiometry in as few words as possible. Cooking with chemistry. We're going to cook. It's just like making cookies, but we're not going to make cookies. We're going to make ammonia. You couldn't feed people with cookies if you didn't have ammonia, because you couldn't fertilize food like we do today. Well, how do you make ammonia? What's the recipe? So let's find the recipe. Well, what you do is you take this substance here, which is nitrogen gas, and you add some hydrogen to it. You get the nitrogen from the atmosphere, and you can get the hydrogen from the electrolysis of water, and then you get ammonia, which is also a gas. But dissolve it in water and spray it on your crops or whatever. Make some fertilizer with it, and it works out pretty good. Not balanced. Can't disobey the law of conservation of matter. So I got 2 nitrogens here. I'll put a 2 there. Balances my nitrogens, but I got to balance my hydrogens now, so I'll put a 3 there. And what this is my recipe for cooking ammonia. And the way that it's written, I can say that 1 molecule of a nitrogen gas will react with 3 molecules of hydrogen gas to create 2 molecules of ammonia. And that is my recipe for making ammonia. If I only made 2 molecules of ammonia, I couldn't do very much with it. That's a microscopic amount of ammonia. I need macroscopic amounts of ammonia. Big, big, big piles. If I was making cookies and I wanted to make more cookies, I would double my recipe. I could make 2 batches. If we made 2 batches of this, if I doubled my recipe, I'd only make 4 molecules of ammonia. I need way more than that. So I'm not going to double it. I'm not even going to triple it. I'm not even going to trillion it. I am going to Avogadro number it. I am going to take and do this recipe an Avogadro number worth of times. And I can rewrite that now in a way, and I'll say, here's my new recipe, 1 mole, because I've Avogadro numbered it, 1 mole of nitrogen will react with 3 moles of hydrogen, and that would create 2 moles of ammonia. Now these are big piles. We're not talking about molecules anymore. We're not talking about microscopic amounts. We're talking about macroscopic amounts. Avogadro's number is a huge number, 6.02 times 10 to the 23rd. That's a lot. Well, how many is that? Well, let's think about the molar mass. How big is that pile? Well, the molar mass of nitrogen is 28, 2 times 14. So I would say that here's my new recipe, right? If I'm going to cook this stuff, I got to start measuring it out. I need 1 mole of nitrogen, right? Well, how much is 1 mole of nitrogen? Well, it's 28 grams of nitrogen. Okay. I got to add 3 moles of hydrogen. Well, how big's that pile? Well, the molar mass is 2 grams per mole times 3. That's going to be 6 grams of hydrogen. So I could weigh out 28 grams of nitrogen. I would react that with 6 grams of hydrogen. And I'm going to do my reaction now with those big piles of substances. And I will make 2 moles of ammonia. What's the molar mass for ammonia? 34 grams. Did I do this one right? I think I did. Okay, let's say I got 14 plus 3 is 17, right? That's the molar mass for ammonia, 17 grams per mole times 2. That's 34 grams of ammonia. That's a big pile. Well, did I even do this right? I did. Check this out. 28 grams of nitrogen is going to react with 6 grams of hydrogen. That is a total of 34 grams of reactants, right? That's the mass of both of my piles of reactants put together. they're going to react. They're going to form a totally new substance that's going to be 34 grams of product. And that, my friends, obeys the law of conservation of mass, right? 34 grams in, 34 grams out. This is cooking with chemistry. I just made a bunch of ammonia, can make some wheat, grow some wheat, make some cookies. I hope you guys get the basics. I probably could have done this in fewer words too, but I like to babble, and I love the sound of my own voice. Thank you for your attention today.